Vanderwaal'S equation. We know ideal gas equation is PV equal nRT. This equation is applicable only for ideal gases. So, a modification of this ideal gas equation is made by Vanderwaal's to make it applicable for all gases. Okay, so at high pressure, what happens? At high pressure, these molecules do not strike on the walls of the container due to molecular attractive forces. Okay, at high pressure, molecules do not strike on the walls of the container. Due to molecular forces of attraction. That is, as the pressure is increased, the molecules gets crowded. So, there will be attraction between the molecules and they do not strike on the walls of the container. So, the pressure of this gas or the real gases will be less than the pressure of the ideal gas. Okay. So, pressure exerted by the real gases will be less than the pressure exerted by the ideal gases. Pressure exerted by the ideal gases. Okay. So, pressure exerted by the ideal gas will be equal to, we have to add a correction factor to the pressure exerted by the real gas. So, P ideal will be equal to P real plus a correction factor A V square by A n square by V square. This is the correction factor we are adding. Where A is the Vanderwaal's constant, N is the number of moles and V is the volume. So, this correction factor we have to add to the pressure exerted by the real gas. Then we will get the pressure exerted by the ideal gas. This is the first term. Okay. Next, what happens to volume? Second case, in the case of volume at high pressure, the volume occupied by the real gases will become significant. Okay, volume occupied become significant. Okay. So, that is, the volume decreases and the volume of the molecules become significant and the volume of real gases will be equal to V minus NB. Okay, we have to subtract a small term from the volume of the ideal gases. Okay, so volume of real gas will be V minus NB. N is the number of moles and B is the Vanderwaal's constant. Okay. So, the total volume of the molecules will be gets reduced. Okay. The volume of the molecule of the real gases will get reduced from the volume of the ideal gases. Okay. So, Vanderwaal's equation becomes we have to modify P plus A square n square A n square by V square into V. V becomes V minus NB is equal to nRT. So, this equation is called as Vanderwaal's equation. Okay. Next, significance of A and B. So, we know Vanderwaal's equation is P plus A n square by V square into V minus NB equal nRT. Okay, where A and B are van der Waals constant. N is the number of moles of gas, V volume, P pressure, then R universal gas constant and T temperature. Okay, now first point, what is the significance of A? A is the magnitude of the attractive forces among the molecules of a gas. Okay, it is the magnitude of attractive forces among molecules of gas. Okay, and its unit is atmosphere liter square mole raised to minus 2. Okay, so as attractive forces increases, A value also increases. Okay, so it becomes significant at high pressure. Okay, as the pressure decreases, what happens? And pressure reaches 0. Pressure is very low. Okay, there will not be any attractive forces between the molecules and the gas will shows ideal behavior. Similarly, at very high temperature, what happens? The same, the attractive forces decreases and A will become insignificant. So this significance of A will happen only at high pressure and low temperature. Okay, next, second, B. Significance of B, it's the measure of effective size of effective size of gas molecules. Okay, and its unit is liter mole raised to minus 1. Okay, so these are the significance of A and B.